Okay, welcome to the video. So today we're going to go through the entire technical mathematics paper one, and this is from 2018, and this is grade 10, technical mathematics paper one. And so this paper would be standard that you should practice, obviously, especially since you're preparing for your exams. So we're going to do these questions in this video. And so let's get started. So we're going to do question one, and we're going to try and do 1.1 to 1.2. Then we'll continue from there. Okay. So let's get started by looking at the very first one here. So the very first one that we have here, if I may just change this up. So the very first one that we have here is basically question one. And the first question actually asks us and says, consider the following, right? Consider the following numbers. And the following numbers is the cube root of 9, the square root of 9, and then the square root of negative 9. So they ask us which one of the above numbers is irrational and imaginary. Okay. So remember, you need to have a very clear idea of what is rational, what is irrational, and what is imaginary. So firstly, what is a number that is rational? A number that is rational is a number that you can write in decimal form and in fraction form, right? And in fraction form. That's the important part. If you're able to write that number as a fraction, then it is an irrational, a rational number. But let's say you cannot write it as a fraction. When you cannot write it as a fraction, then it is irrational. Okay. So in this case, we're looking for a number that we cannot write as a fraction. So when we look at these ones, the first two ones, which are quite clear that cannot be irrational, is square root 9, because square root 9, obviously you can rewrite it as 3, right? And 3, you can write it as a fraction of 6 over 2, right? 6 over 2 is 3, right? So it is definitely rational. And then square root negative 9 cannot be irrational as well, because it's a different type of number. And the type of number that it is, we call it a complex number, right? Because it has a negative inside the square root. So the only clear option that we have that is irrational in this case would be cube root 9, right? So it's cube root 9. So that's cube root of 9. And basically that would be the answer there. So when we're talking about imaginary, remember, it's another word for calling it a complex number. So a complex number would be just square root negative 9. Okay, so it's square root negative 9 and cube root 9. Okay, now they say, between which two integers does 11 lie, right? Which two integers does 11 lie? Now, if they want integers, basically, the whole point here is that you need to find what are the two numbers with this lie in between. So obviously, you have 11, right? So you have 11. And what is the biggest square root that you could think of for 11, and the smallest square root that you could think of for 11, right? So, or perfect square. Look for the closest perfect square to 11 that is bigger than 11, and the closest perfect square that is smaller than 11. So when you think about it, I think 9 is a good perfect square. So we know that 9 is definitely less than 11. But also, what is bigger than 11? That is a good perfect square. You could say that is 16, right? 16, right? And if you square root, then you have the square root of 11, square root of 16, square root of 9. And basically, then you'd get that this would definitely be 3. So the square root 11 is between 3 and 4. right? So square root 11 is definitely between 3 and 4. Okay, so this definitely lies between 3 and 4. It's quite clear that once we do it that way, then we know that it's definitely between 3 and 4. Okay, so basically that's how we did this one. So what do? We take the number inside the square root, right? And we look at the number inside the square root and we ask ourselves, what is the closest perfect square to 11? What is the biggest perfect square but is close to 11, but also the biggest perfect square that is smaller than 11? So the closest but smaller than 11 is 9, because 3 times 3 is 9. But also at the same time, 16 is 4 times 4, which is bigger than 11, right? And then from there, when you apply the square root everywhere, then you can find that this is square root 9, and that's square root 16. Square root 16 would give you 4, and square root 9 would give you 3. And that would give you what square root 11 would be in between. It's between 3 and 4. Okay. Okay, so now let's look at the next questions. Let's get the next question. So the next question now, it's about subtract. It says 11.3. So I'm going to take the rest of the entire paper. So it says 11.3 there, and it says subtract. So let's see what we can do with this one. Okay, so we have to subtract, but what are we subtracting here? So we're actually subtracting, it says here, so it says subtract 3x squared minus 5x minus 7 from 7x squared minus 2x minus 6. Well, this is a very straightforward question. They're actually telling us what to subtract. We have to subtract 3x minus 5x minus 7 from, right? 7x squared minus 2x minus 6. So what do we put in front? So this is 1.3. So this is 1.3. So it says it's from 7x squared. So we have to start with 7x squared in front minus 2x minus 6, all right, minus, right, because it's subtraction. So we wrote the first expression first, which is 7x squared minus 2x minus 4, because they said it's from. So they're taking out 3x squared from 7x squared minus 2x minus 6. So that's why I put it in brackets. So it's 3x squared. Then it's minus 5x. Then it's minus 7. Okay. So there we have it, right? And so now we need to just simplify. So in this case, then it's 7x squared minus 2x minus 6 minus 3x squared plus 5x plus 7. Now, how did that happen? Remember, because it's a negative sign outside the bracket, it changes all the signs. So this is a positive 3x squared. So we change it now to negative 3x squared. This is a negative 5x. We change it to positive 5x. And negative 7 changes to positive 7. Okay. And now the next step is to add the like terms. What is the like terms and how do we see them? We see them through the variables, right? So if the variables correspond, then we can add or subtract those like terms. So what are the like terms that we see here? So firstly, I can see that 7x squared is a like term to negative 3x squared. So 7x squared minus 3x squared, that would be 4x squared, right? And then 5 minus 2x, right? This is minus 2x. The like term to it would be plus 5x. So this would become what? It would become positive 3x, right? And then here it's minus 6 and plus 7. So minus 6 plus 7 would just give you plus 1. So now we've subtracted, and that's exactly what they asked us to do. They said subtract, right? They said subtract 3x squared minus 5x minus 7 from 7x squared minus 2x minus 6. And that does give us what we've just gotten, which is 4x plus 3, 4x squared plus 3x plus